Hey, hello everyone. So we continue to solve exercise related to binary trees, and today we have an exercise which is called binary tree right side view, which is of medium level. And let's check the condition. The condition said that we will need to create a method that returns the values of the nodes. You can see ordered from top to bottom when imagining yourself standing on the right side of a binary tree. So we will need to create a method which will take an argument root, which is this one, and our method should return a list of integers representing the right side profile. So again, let's imagine that we have this tree and we standing on the right side of this tree, and what we will see? We will see these nodes, 1, 3 and 6. So yes, and also 7, because here we don't have node and we will have a possibility to see this node. So I hope that the condition is clear, but before to continue, I would really suggest you to watch the previous videos, because there we have a video which shows how we can use white first search, and there I describe how level by level search is working. And actually in that solution for that task we will use approximately the same approach which we have used there. So it would be very useful for you to watch that video. So now let me show you a visualization of this algorithm. So let's imagine that we have this subtree, and what we will do, so we will start from the first node and from the first level, and in that level we have only one node, which is the last node and the first node. But the most important thing is to understand that it's also the last node here. And we will place it in our result list, and we will go to the next level. The next level now contains two nodes, 2 and 3, but for our task it's more important to take only the last element, which is 3, and we will put this element inside our list. And now in our result list we'll have two elements, 1 and 3, and when we will iterate through all elements from that level, we will put in our result list only the last element, and we'll continue with the next element in the next level. In the next level we have two elements, 5 and 4, and we will place just the last element from that level, which is 4. So the result in the result we will have a list with elements 1, 3 and 4. So that's the idea of the algorithm. So now let's proceed and check how we can solve that task. So here I have already prepared the structure of our node, and also I have prepared the signature of our method. Here we will have an argument which is root of our node, and we will return a list with our values. So let's start to implement this method. Again, I really recommend you to watch the previous videos where I explain it more in detail, because here we will use the same approach but with a small change. So first of all, let's here put a condition that if root is equal to null, that then in that case we will return an empty list. So let's write this condition. So if root is equal to null, then in that case we will need to return an empty list. Let's initially create that list where we will store our results. So list of integers, we'll call it result, is equal to new array list, and that's it. and here we just will return this this empty list. Perfect. Now let's create a queue. If you remember in the previous exercise, or maybe if you are familiar with depth first search, in that cases we used recursion. In that case we will not use recursion, but we will use a queue, yeah, where we will store elements from each level. And for that we will need to use while, because we don't know how much iterations we will need to process, but we know that we will stop to iterate through we need to stop to iterate through our tree when in our queue we will not have elements anymore. So let's write this while and put here a condition, but before to put this condition, let's first create this queue which will store our nodes. So here we will write tree node, we'll call it queue is equal to new linked list. So a linked list is one of the implementation of the queue, if you are familiar with Java. If not, now it's not very important, but like a small information for you. And the first element which will be placed in our queue is the element from the first level, but the element from the first level is root, which we send like argument. So let's put this element in our queue. And also a small information that queue is working by principle first in, first out. So the first element which we will put in our queue will be processed. And now let's here put a condition that it will work until that moment it's not empty. So if queue is not empty, we need to process what is inside our while loop. Okay, perfect. And now we somehow need to know how much elements from that queue are from the current level, because in that queue we can put also element from the next element from the next level, but we are still processing elements from the current element, and we need to know when we processed all elements from that level but not from next level. Yeah, and how we can know this? We can know this by doing something like that. So when we just started this while loop, in our queue we will have only elements from the current level which we are processing right now. During the while we can add some additional elements from the next level, but when we start the loop we will have elements from the current level which we haven't processed yet. So we can know how much elements are in the current element just to know how the size of the queue. So let's declare here a variable level size, and let's get the size of the queue. Perfect. And now let's declare here a for loop, and in I is equal to 0, and here inside this for we will process elements from the current level. So let's write something like that. I is until I is less than level size I plus plus. And what we will do inside this for? So inside this for we will get the elements from the queue, and we just will take the last element from the current level and will place in our result list. So let's put here a condition. So if first of all we need to get the element from the current iteration. Tree not current not is equal to q poll. Poll is a method which extracts an element from the queue and removes it from the queue, because it's very important, because if we would not remove the element from the queue, this while will process infinitive time, because we always would have elements and we will just add some additional ones, but we need to add them, process and remove. Yeah, so we need to remove them. So we get the queue, but this is we get the element, but this is not enough. We also need to check if this element is the last one from the current level, so we can write this condition. So if I is equal to level size -1, so the index of the last element, then in that case we can add the node in our result list, and here we'll write current node. And the last thing which we need to do, actually here we need not node but value. Yeah? And the last thing which we need to do, we need to check if current node has some elements in the left subtree. So here we'll write left is not equal to null. Then we will need to add this node inside our queue. And the same for right side. Okay, and in the end we just need to return our result, our list. So that's the solution. Now let's check the complexity. So the time complexity is ON and the space complexity is OW. So I hope that my explanation and that the solution was clear. Again, if you have any questions, please write in the comments. I will try to help you. And I hope that we will see you in the next video. Bye.